Partial variation consists of two or more parts added together. Let me explain further. If two variables x and y is given, and you're told that x is partly constant and partly varies as y, then the equation that you need to write is equals to a plus ky, where a and k are constant. In another situation, we can have two variables u and y, and you can be told u is partly constant and partly varies inversely as y. So the equation that you need to write is u is partly constant, which we write only the constant, and then partly varies as y is we write the constant k divided by y. So as you can see from these two equations, partial variation normally has two constants. As you can see from the two equations I've already written, it is a and k, as opposed to any other kind of variation like the inverse variation or the direct variation we've seen in a previous video. We can have another example of partial variation. Suppose we have two quantities which are partial variation. If b varies partly as c and partly as a square of d, so b varies partly as c, which means now our constant a is going to have another variable c, then plus our constant k will have another variable d, but this time it is squared. So this equation represents this statement: b varies partly as c and partly as a square of d. So as you can see from these statements, there are two partlies, partly. So when you see two partlies, we must include the two constant, the variables that the question is giving. So in this case, we have the variable c and the variable d, and both of them have constant. Now we can proceed to this question. Now we want us to read this question carefully and see which kind of partial variation is it. The mass of a wire, m gram, is partly constant and partly varies as a square of its thickness t. So let's call the mass, let us put the mass m and the thickness t. So from these three equations, what do you think is the equation we want? Obviously, from this statement, the equation you want is this one, only that we have included a square here. So in this case, the variable x is replaced with m and the variable y is replaced with t. So in this equation, first we write the equation in form of m and t. The mass of wire m varies partly as the constant, let's put the constant a, and partly varies as a square of t. But this time we include the constant k. Like I said before, that this type of variation has two constants, which is a and k in this case. So we use this equation. Let's write this equation very well. We use this equation m equals to a plus kt squared. So we use this equation to form other equations using the variables given here. So we're told when t equals to 2, m is 40. So 40 equals to a plus k times, in this case t is 2, so t squared. So this is the same as a plus 4k. So let's call that one equation. 40 equals to a plus 4k is one equation. The other equation we can draw is when t equals to 3, m is 65. 65 equals to a plus k times t is 3 squared, so this will be a plus 9k. Let's call this equation 2. So we take this equation and solve them simultaneously. The first equation is 40 equals to a plus 4k. The second equation is 65 equals to a plus 9k. We use elimination method to solve this. We subtract the two equations, and when you subtract them, we get negative 25 equals to negative 5k. Dividing both sides by negative 5, we get k as positive 5. Well, now once we get k, we can go back to either of the equations and get the value of a. So 40 equals to a plus 4 times 5, and therefore a equals to 40 minus 20, and that is the same as a equals to 20. Now we can write the equation connecting m and t. Using this equation, we can replace a and k with equals to 20 plus 5t squared. Now the question is asking us to determine the value of m when t is 4. So m will be what when t is 4? So m will be 20 plus 5 times 4 squared. So that is the same as 20 plus 5 times 16, which is the same as 20 plus 80, and therefore m, which is mass, is the same as 100 grams.